Assalamualaikum and hi, my name is Muhammad Shafiq Berazaudin. My matric ID is CA21104. So I'm from GroupCable. We are going to testing and optimize. Assalamualaikum and hi, my name is Muhammad Shafiq Berazaudin. My matric ID is CA21104. I'm I'm from GroupCable. We are going to present testing and optimizing network design. First of all, I will introduce our group members. Firstly is myself, and the second one is Abdullah Hamad Al-Lodaini. The next one is Darwin anak lelaki Raja Amaran, Wan Hazi Ozai, Wan Hamizi, Muhammad Zahin Afan bin Zainal Abidin. The last one, Muhammad Fahmin bin Dahlan. So, what are the reasons to test the network design? To verify that the design meets key business and technical goals, validate LAN and WAN technology and device selections, verify that a service provider provides the agreed-up service, identify bottlenecks or connectivity problems, determine optimization techniques that will be necessary. How to test your network design? So you can use industry testing services, build and test a prototype system, use third-party and Cisco tools. What are industry testing services? So there is some of industry testing services. You guys can follow the URL to get more information about their industry. Scope of a prototype system. What is a prototype system? A prototype is an initial implementation of a new system that provides a model on which the final implementation will be patterned. It is not generally practical to implement a full-scale system. A prototype should verify important capabilities and functions that might not perform adequately. Risky functions include complex, intricate functions and functions that were influenced by the need to make a trade-off. Cisco tools. Cisco tools offer an easy way of monitoring your Cisco routers, switches, etc. effectively through SNMP. The Cisco management tools help to troubleshoot Cisco devices quickly. Cisco Router Monitoring Tool offers a wide range of monitoring information you require about the router, such as the name, description, flash memory of a router, the chassis details of a router, the static and dynamic routes of a Cisco router, and more. So these are the example of prototype network and example of Cisco tools. That's all from me. I will pass to the next presenter.
Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Hazil Ozai bin Wan Hamizi. My matric number is 818090. Alright, I will continue the presentation after being passed by my group member. Alright, there are a few components of a test plan. Alright, the first one is test objectives and the acceptance criteria. The second one is the types of tests that will be run. And then we have the network equipment and the other resources required. For the fourth one, we have the testing scripts, and the last one, we have the timeline and milestone for the testing project. Alright, moving on. For the test objectives and the acceptance criteria, it must be specific and concrete. Besides that, it must be based on business and technical goals. For the objectives and the acceptance criteria, it must be clear criteria for declaring that a test has failed or passed. It is to avoid biases and preconceived notions about the outcomes. So, If it is appropriate, we need to reference a baseline. Alright, moving on. So we have a few types of tests. Alright, the performance analysis should examine the level of service that the system offers in the terms of throughput, delay, deliberation, response time, and efficiency. Typical tests include the following, which we have four types of testing, which is the first one is application response time testing. Alright, this type of test measures performance from the user point of view and evaluates how much time a user must wait when executing typical operations. The second one is the throughput testing. This type of test measures throughput for particular application and throughput for multiple applications in kilobytes or megabytes per second. So, the third one is availability testing. So, with availability testing, tests are run against the system for 24 hours to 72 hours under a medium to heavy load. The rate of errors and failures is monitored. The last one for the type of test we have the regression testing. Regression testing makes sure that the new system doesn't break any application or components that were known to work and perform to a certain level before the new system was installed. So, these are the few lists of the resources needed for testing. So, for the testing, we need to schedule a time in the lab either at your side or the customer side. So, when doing the testing, we need power, air conditioning, rack space, and the other physical resources. We might need help from co-workers, customer staff, or any users to test the applications. We must ensure that we already know the network addresses and each names. Alright, so that's all from me. Thank you.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdullah Hamoud Aladini. I'll speak my part test script example. First one, I will show this diagram. This diagram is a simple test script for the network environment. Here on the right side, network B, server 1, on the left side, it will be network A station. And between them is the firewall. Is to block these two networks. Before I start to in testing step, I will point 2 points. First, the first point is test objective is to assess the firewall capability to block the application ABC traffic, and then the acceptance is to make the firewall block the TCP request from application network A. Then to set up application ABC session with the server 1 on the network B. And then the firewall should reset this packet. And then I will go to the testing step. First step is starting capture network on the protocol analysis on A, and then on the network B. Then we will run the application ABC in network A. After that, we will stop the capturing network traffic. And then we will display the data network protocol analysis and verify the protocol. And then we'll go to the step 6. We'll display the data on network B protocol analysis. Before I go to step 7, why we will display the network protocol analysis? To verify that the analysis didn't capture any application ABC traffic on the workstation. And then the step 7, we will look the result of the test in the project log file. Then and 8, we will save the protocol analysis to project as file. Then this is the last step, number 8. Number 8, we will increase the work load of the firewall. So by increasing the number of workstations on the network one at a time until 50 workstations are running application EPC and attempting to reach server 1. Then we will repeat all these steps from 1 until 8. After each workstation is added to the here there are some tools useful for testing the network, also simulator this processing. And why we using this? Or because we using this software because it will to analyze the behavior of the network without requiring an actual network. Also, this simulator tool lets you also develop a model for a network to estimate the performance of the network and compare the alternative of for implementing network. This is my topic. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmin bin Dahlan, contact number CA21103. Today I want to present about top-down network design. Optimizing your network design. First, the reason to optimize. Six reasons to optimize. First is meet key business and technical goals. Second is use bandwidth efficiently. After that, control delay and jitter, reduce serialization delay, support preferential service for essential application, and last reason is meet quality of service QoS requirements. After that is IP multicast help optimize bandwidth usage. First, with IP multicast, you can send a high volume multimedia stream just once instead of once for each user. Secondly, it requires support for multicast addressing, multicast registration, IGMP, and also multicast routing protocol. So next slide is IP multicast addressing. Uses class D multicast destination address 224.0.0.0 to 239.255.255.255. After that, convert to a MAC layer multicast destination address. The lower order 23 bits of the class D address become the lower order 23 bits of the MAC layer address. The top 9 bits of the class D address are not used. The top 25 bits of MAC layer address are 0 times 01 0050 followed by a binary. Okay, next is Internet Group Management Protocol (IGMP). Allow a host to join a multicast group. Host transmits a membership report message to inform router and the segment that traffic for a group should be multicast to the host segment. Last is IGMP v2 has support for a router more quickly learning that the last host on a segment has left a group. So next is multicast routing protocol. There are two multicast routing protocol. First is becoming obsolete. First is multicast OSPF or MOSPF. Then distance vector multicast routing protocol (DVMRP). The second one is still used. Protocol Independent Multicast (PIM), um, Dense Mode (PIM), and Sparse Mode (PIM). After that is reducing serialization delay. First is link layer fragmentation and interleaving. Break up reassemble frame, multi-link PPP, and also frame relay FRP.12. Compressed real-time protocol (RTP) is used for voice and video. Compressed RTP compress the RTP, UDP, and IP header from 0 byte to 2 to 4 byte. This is a few technology meeting for QoS requirement. First is IETF control load service, IETF guarantee service, IP precedence, and IP differentiate service. So the last is IP type or service field. The type of service field in the IP header is divided into two subfields. First subfield is the 3 byte precedence subfield support 8 level of priority, and the one is the 4 byte type of service subfield support 4 type of service. Although IP precedence is still used, the type of service subfield was hardly ever used. That's all for me. Thank you.
Assalamualaikum and good morning. My name is Muhammad Zain Afan bin Zainal Abidin, metric number CA20092. I will continue to explain about IP type of service field. Here is graphic presentation of the type of service field. First, we have bit 0 from 2. We have precedence. And then type of service subfield. Here 3 is D, 4 for T, 5 is R, and 6 is C, and 7 is 0. As we can see here, from the hint, D is for delay, T for throughput, R for reliability, and C for cost. And we go down here, from bit 0 until 7, we have version, header length, and from bit 8 until 15, we have type of service, and from 16 until 31, we have the total length. And then we go down here, we have identification, and below here, we have time to live and protocol. And here we have the total length, flags, fragment offset, and header checksum. And below here, we have the source IP address, and then destination IP address. Below here is options and padding. So here is the IP type of service field. Next, we move on to differentiated services, or DS. RFC 2474 redefines the type of service field as the differentiated service field. Bits 0 through 5 are the differentiated service code point subfield, or we can call it DSCP. It has essentially the same goal as the precedence subfield, and it influences queuing and packet dropping decisions for IP at a router output interface. Bits 6 and 7 are the explicit congestion notification subfield, or we can call it ECN. So here is the graphic presentation of differentiated services field. From bits 0 until 5, we have the DSCP, and from 6 until 8, we have the ECN. And when we go below here, from 0 until 7, we have the version and header length. From 8 until 15, we have the differentiated service, and 16 until 31, we have the total length. So then we move on to classifying LAN traffic. IEEE 802.1p is a protocol that defines the mechanism to prioritize traffic. It provides a better quality of service so that it has better reliability and quality. It classifies traffic at the data link layer. It supports 8 classes of service. The switch can have a separate queue for each class and service the highest priority queues first. And then we move on to Cisco switching techniques. First is process switching, fast switching, net flow switching, and Cisco Express Forwarding or CEF. And then we move on to Cisco queuing services. The first queue is first in, first out queuing or FIFO. FIFO is the most common used queuing method. And then is priority queuing, custom queuing, weighted fair queuing, WFQ, class-based WFQ, and low latency queuing, LLQ. All of this queuing service will be explained by my friends in the next slide. That's all from me. Thank you.
A very good evening to my fellow friends and to my lecturer. My name is Darwin, CA19113. I'm from GroupCable, and today I would like to explain about Cisco queuing services. As my fellow friend have explained about Cisco queuing services, so I would like to explain further regarding Cisco queuing services and types of Cisco queuing services. So before moving to the, first of all, I would like to explain to you about priority queuing. Okay. As you can see here, in computer science, a priority queuing is an abstract of a data type which is similar to a regular queue or stack data. Okay, so in which the element has a priority associated with it. As you can, in priority queue, an element with high priority is served before an element with a low priority. So if you see the table here, you would understand is the diagram here. A packet in high queue is served first compared to the packet with low queue. So this is what they call as priority. So this is a priority example of a priority queuing. So moving to the next, we're going to look at custom queuing. Custom queuing is a type of queue. Custom queuing is a type of queue, allows a customer or user to reserve a percentage of bandwidth for specific protocols. So customer can define up to 10 output queue to normal data and additional queue for the system messages such as LAN, keep alive messages, like routing packets, and routing packets are not assigned to the system queue. So, okay, next we are going to look about low latency queuing, which also known as LLQ. Okay, so basically, low latency queuing (LLQ) is a feature developed by Cisco to bring a strict priority queuing to class-based weighted fair queuing. LLQ also delay sensitive data such as voice to be given preferential treatment over other traffic by letting the data to be dequeued and sent first. So that is the main purpose of low latency queuing. Okay. Okay, next is random early detection, which is also known as RAID. It's a congestion avoidance rather than a congestion management. So in this RAID, they prefer to avoid conjunction. So monitors traffic loads and randomly discard packages congestion increase. Means so source nodes detect drop packets and slow down to work its best with TCP. So weighted randomly and random and early detection. Okay. Okay. Next is traffic shaping. Okay, traffic shaping is to manage and control network traffic to avoid bottleneck, avoid overwhelming a downstream router or link, and reduce outbound traffic for a flow to a configured bit rate, which is a queue burst of traffic for that flow. So meaning, as we know in network traffic, as the traffic increase, the network, the struggle for the user to use the network will be higher. So this is to traffic shaping is to avoid the bottleneck to happen. So moving to the next is a Cisco committed access rate, which is known as CAR. Is a Cisco feature for classifying and policing traffic on an incoming interface. It supports policies regarding how traffic that exceeds a certain bandwidth allocation should be handled, and can drop a packet or change the IP precedence or these DSCP bits. So as a conclusion, optimization provides a high bandwidth with low delay and control jitter required by many critical business applications, and to minimize bandwidth utilization by multimedia applications, use IP multicast. To reduce serialization delay, use link fragmentation and compressed RTP, and to support QoS optimized performance, use IP precedence DSCP 802.1p, advanced switching and queuing method, RED, CAR, and etc. Okay, that's all from me. Thank you very much.